Hello and welcome back to Higher Maths Integration. Quick reminder, what is integration? Integration undoes differentiation. Why would we integrate? We'd normally integrate to find the area between a curve and the x-axis for given values of x. Again, we'll look at that later on, but that is the reason why the normal reason why we integrate in Higher Maths. So we'll look at question 1 to 4 in lesson 1A. This is lesson 1B, so we're going to look at questions 5, 6, and 7. So reminder, to integrate, we add 1 to the power, so negative 3 over 2 plus 1 is negative 1/2, and then divide by the new power, so divided by negative 1/2. So here we need to tidy this up. We have 4 over negative 1/2, so that's the same as 4 multiplied by negative 2 over 1, which is just 4 multiplied by negative 2, which is negative 8. So we'd have negative 8x to the power negative 1/2 plus c. Remember, we need that constant of integration when we are doing an indefinite integral, because if we differentiate this, we get back to 4x to the power negative 3 over 2. But if we differentiate this plus 1, we would also get back to that. If we differentiate this minus 57, we'd also get back to 4x to the power negative 3 over 2. So we must have this constant of integration to show that there could be a number term on the end. Question number 6. Actually, before that, it can be easy to confuse integration and differentiation, which is very true. I see that a lot. Nobody's doing that on purpose, guys. Remember, integrating, we add 1 to the power, divide by the new power. If we're differentiating, we're multiplying by the power, reducing the power by 1. Okay, so there may be a little bit of confusion between the two at some point, but hopefully after you've covered both in class and then started to revise properly for future assessments, you'll start to notice the difference and stop making that mistake. Right, other variables. So question 6, find the integral of 2p to the negative 5 dp. So that is basically telling us to integrate with respect to p, or in other words, integrate the p's, not the x's. So add 1 to the power, divide by the new power. So 2 over negative 4 is just negative 1/2. So we'd have negative 1/2 p to the negative 4 over 2. So we just wouldn't write the 1 on the top there, just be negative p to the negative 4 over 2 plus c. Question 7, find the integral of p dx. So here p is just a constant term. It's nothing to do with x whatsoever. So it's just like integrating 5 dx or integrating 7 dx. It will just be whatever this term is followed by an x. Quick check, if I differentiate px, I just get p. If I differentiate the plus c on its own, I get 0. So if I differentiate this, I do get back to p. And integrating several terms at once. So just like with differentiation, we can differentiate more than one term. We just differentiate each one as we go. So it'll be the same with integration. So add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power here. So we end up with 2 over 3 over 2. Again, dividing by 3/2 is the same as multiplying by 2/3. So that would be 4/3. 3/3 here is 1. So we're just left with x cubed minus 4/3 x to the power 3 over 2 plus c. Remember, we need that constant of integration. I know I keep on repeating it, but some of you guys will forget it. And question number 9, exactly the same. Add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. If I integrate 7, I'll get 7x, because if I differentiate 7x, I will get 7. We are undoing differentiation, plus the constant of integration there. So where did the 3/8 come from? Negative 5/8 plus 1 is negative 5/8 plus 8/8, which will be 3/8. That's where that's come from. And then 4 over 3/8 would be 4 times 8/3, which is 32/3. And that gives us our final answer there.